So what I want to look at, you all have your character tables. You have diacetyl. This is responsible for the smell of butter on buttered popcorn. So it kind of looks like this. Remember that a double bond is still just one bond, okay? Now, having a single bond in the middle, we can kind of twist around here. Why might I have given it to you in this orientation? Okay, and what's good about trans? Say that louder. So I told you electronegativity is a good answer, but in this case, a little bit more about sterics. So big things want to get out of each other's way. Okay. It can twist around, but we're going to look at it as if it's flat. So I've got C, H, O, C, O, H. I'm going to leave out lone pairs for the moment. Okay, so what is the largest order rotation I can have on this model? Abby says 2. Anybody find anything higher than 2? No. All right. Is that going in sideways, going in from above, or coming out of the board? Is this the C2 axis coming out of the board? This the C2 axis going upwards, or this the C2 axis going sideways?
Wait, sideways, like you reverse it like that. Maybe.
So if I do this and rotate, my oxygen ends up on top, my hydrogen ends up on the bottom, so it's not that one. If I do this, my oxygen ends up over here, my hydrogen ends up over here. So it's coming out of the board. This is going to rotate to here. This is going to rotate to here. Okay, so we are looking down the C2 axis, and the C2 axis is going to be our Z axis, right? So Z is at us, and we'll call this direction Y and this direction X. Okay, now I'm going to erase some of that stuff so I don't have too many things cluttering stuff up. All right, so it's C2. And we established we don't really have a perpendicular one, right? Okay, so now we're in the C groups. So our next question, whether we're in C or D groups, our next question is what? Perpendicular to this. Is there a mirror plane? Okay, so is the plane of the board a mirror plane? Hint, if you have a planar molecule, there is a mirror plane. Okay, so yes. So this is going to be C2H. All right, and let me make sure this actually started because I didn't see. Okay, good. So this is the C2H group. So find that on your character tables. Oops, everything got turned upside down here. All the different things. Where's my character table? Okay, so what we're going to look at is bending modes. So to find stretching modes, we look at the bonds themselves. To find bending modes, look at bond angles. So I've got these two, hydrogen, carbon, oxygen, that are the same thing. Okay. I've got to be careful about this one. This is an angle, but not this whole thing. That whole thing has 4 atoms. So an angle has 3 attached atoms. So this is, I'm going to call this A. There's 2 of them, but That's one kind of angle. This is B. And then C. Okay, so I have three kinds of angles. Now I could look at them separately, or I could look at them as a group. So we're going to look at them as a group, and we're going to build a representation in the C2H group. Okay. So I have 6 angles. My basis is the angle, so I'm going to put angles down here. And since that's my basis, I'm going to put a 6 there. So however many objects I have a nice spring break. However many objects I have, that's what that's what I write down for the E. Okay. So then I have to go through each thing and decide how many of those angles stay in the same place. Now, angles don't have directions. Okay, so if the center atom of that angle stays where it is, and we're just flipping around it, then we say that it stays in the same place. All right, so I've got this. When I do my C2, I'm doing this. Okay, so do the A's stay in place? They swap positions. Okay, so swapping is not staying in place. Okay, do the B's stay in place? No, they swap. Do the C's stay in place? They swap. Okay. Then for inversion, remember I'm going to go through the center of the molecule, which is at the middle of this bond, out to the other side. So there's the hydrogen. For the angles, A going to A, well, they're swapping again, right? Because this A is going through the center out to the over here. Now, when you have an inversion center, your element is a point, this point, and the only things that stay in place are at that point. Do I have an atom at this point? No, so all the angles have to move. All right, so this is going to swap places with this. This is going to swap places with this. Okay, what about the sigma H? They all stay in place because that's the plane of the board. Okay, we have 6. So that is making a representation, creating a representation. Now, is this all the vibrations? So let's think about how many vibrations would there be? We have 1, 2, 3, 4, 5, 6 atoms. How many degrees of freedom? 18 degrees of freedom. So how many vibrations? 12 vibrations. We only have 6 of them that are bends. Okay, so we're not getting all of them. Some of them are going to be these guys stretching. So I have 1, 2, 3, 4, 5 that are bonds. Okay, each of those can stretch. So that accounts for 5. And then this is a planar molecule. So I can have one more that is twisting out of the plane. Okay, so that's how we would make a representation. Now, how do we reduce a representation? We do multiply 1 times 2 times 3 things. Okay, so let's do AG. Let's see, am I in the right one? Let's do AG and BU. So AG, usually there's one of the symmetric ones. We'll see what happens. All right, so AG has 1s all the way across. So I'm going to take 1 times 6. Here I'm doing times 0. Here I'm doing times 0. Here I'm doing times 6. And since these are 0, I'm not even going to think about those anymore. Okay. But then I also have to multiply by the coefficient. So in this case, they're invisible ones. Don't forget them. 1, 1. I add that up and I get 12. Am I done? What do I have to do? Divide by the order, which I get by saying 1 plus 1 plus 1 plus 1. If there were 2s in there, then I'd have to multiply by 2s. So we're gonna divide by 4. And that means 3 of these 6 are AG. Now that makes sense because I have 3 types of bonds. So probably there's one of each of them that that fits into that category. All right. So I have an A where both of these are doing the same thing. I've got an A where both B's are doing the same thing, and I've got an A where both C's are doing the same thing. I don't know what the other one is. I didn't do this ahead of time, but it might be BU. All right, so I look for BU. B is -1, I'm sorry, 1, -1, -1, 1. So 1 times 6 times 1 times 0, so I don't worry about it. 1 times 0, so I don't worry about it. 1 times 6 times 1. And so I end up with the same thing. 3BU. Okay, so my 6 bends are broken into 3 bends that are AG and 3 bends that are BU. And probably the BU, usually they're like opposites. One is going in and one is going out whenever we have a B. So I squeeze this gets bigger. I squeeze this gets bigger. They're opposites. Okay, you don't have to describe them. Don't worry about that. All right, now, am I going to see any of these in the IR? That is a great question. Very similar to one you might see on your quiz in a few moments.
Oh, good lord. Okay.
You said which one are?
IR, where are you going to look?
Okay, I see the second one. This, or second.
No.
Second to last column. All right. So in the C2V group, all of these will be visible. So those are IR. Yeah, remember you're in C2H, not C2V. We've used C2V a whole lot. It's going to show up on your quiz, but it's not this particular.
We use also in the AR, IR, but we don't have any.
But we don't have any AUs, right? So even though AU does appear in the IR, it's not one of our modes, so we're going to ignore it. Okay, we don't have any AUs. All right, so what about ramen? AG and BG.
AG, but we don't have BG.
But we don't have any BG. So these 3 will show up in the ramen. All right. That's about it. Right after spring break, I'm going to take a quick detour before chapter 5 to look at naming of ligands, because we're going to, in chapter 5, talk about how we attach ligands to different things. And so I want to be able to talk about compounds using their names. So in chapter 9, and I think it is the first section. Double check. Oh, no, section 9.3. All right, what I'd like you to do is take a look at the table that is in there, and there's like a whole bunch of things on there we're not going to worry about. But look at the pattern for the top part of the table where we have fluorine is called fluoro or fluorido. Chlorine is called chloro or chlorido. Iodine is iodo or iodo. Iodido. Iodido. There's a lot of vowels in that one. So just look at the top part to kind of get a familiarity with how you name those things, and notice the difference between things that are anions, negatively charged, and things that are neutral, how those names are different.
9.3.
So 9.3 is the section, and I think there's only one table in here. Oh, there's 2 tables, the top table. So we're not going to memorize all of those. I'll give you a list that you need to know the names of, and it's going to be our common things, the halogens, ammonia, water, those kinds of things. We need to know the names for those. We won't go with exotic things. So take a look at those, see how those ligands are named. All right, questions about that? Okay, questions before your quiz.